Okay, here on example 5, we're looking at characteristics of the sine and cosine functions. So they're giving us an example here with an object on a spring that is oscillating according to the function y equals 40 cosine of pi t, where t is our variable. So where y is the distance in centimeters above its equilibrium position. So something on a spring, it'll have some equilibrium position that it's like oscillating above and below. So they're saying y is the distance above its equilibrium position at time t seconds. We want to find the period and the frequency, and then we want to identify the domain and range. So how I would suggest proceeding on that is first let's start by doing just our simple cosine graph. Now we want, as soon as we see pi anywhere close to a sine or a cosine equation, we want to change our degrees into radians. So rather than 180 and 360, we'll have pi and 2 pi. Our cosine graph is going to go from its maximum value to its minimum value and back up to its maximum. And based off our amplitude here, we're not expecting it to have a maximum of 1, we're expecting a maximum of 40 and a minimum of negative 40. Okay, now last thing is here, cosine of pi t. So if this was just cosine of t, we'd expect to reach a full cycle at 2 pi. Now, since we're multiplying anything we start with by pi, that means that we are going to reach this location. We're going to reach a full rotation at 2 units of time. So we're saying t is in seconds. So at 2 seconds, we should have done a full rotation. So think about how that would work. If I put in a 2 here, I'm just going to get cosine of 2 pi. Well, cosine of 2 pi will be our maximum value. We will have gone around the unit circle. Cosine, which is the x position around this unit circle, once we've done a full 2 pi rotation, we will have a cosine value of 1. We'll kind of be back where we started, right? So we start out up here at 1, and as I go around my unit circle, I complete my full rotation on the cosine graph at 2 pi. Okay, so that's kind of what I'm trying to achieve here. I'm trying to get it so that when I put in if I put in 2 for time, then I'm doing cosine of 2 pi, and I'm getting my maximum value of 1, which I multiply by 40 to get the maximum value on my graph. Okay, if I put in a 1 here for the time, 1 second, then I'm doing the cosine of pi. Okay, cosine of pi is over here, and that is that negative 1 value. That's where we're getting to the bottom of that cosine graph. Okay, so if I put in a 1, I'm expecting my total y value to be negative 40. Negative 1 for this chunk times 40. Okay, so I think that would be the graph we want. Now, based off what they're asking for, so we want the period and the frequency. So the period on this one is going to be 2 seconds. Our cycle takes 2 seconds. Okay, so we can write that out. Our period is 2 seconds. Our frequency is how many times do we do a rotation every second? Well, every second we only do half a rotation. We haven't even done the full one in 1 second. But a different way of saying that is it's always 1 over the period. So in this case, it's 1 over 2 is my frequency. Every second I do half a rotation. So frequencies is going to be 1/2 rotations or cycles, whatever word you want to use there, per second. Okay, those are the units of frequency. It's number of events per second. The period is how many seconds it takes for 1 full cycle to be completed. Okay, so that's kind of what we need there. Now the domain and range, well, the domain is going to be all values of t. There's not going to be any amount of time that we can't use on the x-axis. There's not any number we can't put in. And the domain, um, well, you know, let's say in the context of this situation, the domain maybe we should limit to 0 seconds and above, right? Because we're not, if we describe t as in, I guess it just says t seconds, but let's say t seconds since release. Let me add a little detail onto this paragraph to kind of constrain how we do this. So if t seconds was t seconds since release, then we could have 0 seconds since release. We wouldn't really want to pay attention to the time before we started watching the spring oscillate. As far as the range goes, that's going to be from 40 to negative 40. So that's just very simply the highest point to the lowest point in the y direction. And that is what it would take to take this equation here and graph it and identify these features in the context of the situation. So that is it for example number 5.